Okay, sir.
Okay, so first of all, let me share some PDF. Okay, some basic thing. Okay, first of all, I'm sharing a screen. Okay, so
Okay.
today I'll show you some basic things, basic of the signal system. This slide, this sheet I have taken from the MIT. Okay, MIT from the America. So from them, I have taken these few slides, and also I have some local slides. Okay, I'll show you one by one. So first thing first, at first of all, do you know what is the time domain and what is the frequency domain? Do you have any idea? Time domain and frequency domain.
No, sir.
Okay. Uh, the oscilloscope we have in the lab, it shows in the time domain. Okay. Oscilloscope shows in the time domain. On the other hand, if you let's draw a signal. Mm, let's say three color, different color. Say that is a signal. Okay, and let's draw another signal. Two signal, right? Two signal in the,
Yes.
that is actually the time domain. That is T. So that is Y. T. Okay, that is our time domain representation. Time domain. That is time domain. That is our time domain representation. If I want to see it in the frequency domain, then what I'll see, that is actually F. That is another term, the amplitude. The what we'll see signal like this. If you look at the frequency domain, you can see the signal like this. Maybe something like that. We'll see something like that. Okay, that is the frequency domain. In the frequency domain, we will see something like that. That means if you have multiple signals, then you'll see a pulse. Some pulse will be there. Okay, pulse train. You'll see the pulse train at the different times. Not like this. That is the frequency domain. Okay, now see signals. That is the continuous time signal. See the continuous time signal. This kind of signals are called the continuous time signal, xt. signal is small xt. That is one dimensional, that is a t. Okay, that is the continuous time signal. Now the discrete time signal, like this. That means the value changes at different times. Discrete time. That is the discrete time signal. Okay, that is the discrete time signal. Like this. See, -3 a amplitude, -2 at another amplitude, at -1 another amplitude, at 0 another amplitude, at 1 a amplitude, 2 a amplitude, 3 another, 4 another. Here some. Okay, infinity. So representation, just look at the representation. Discrete time signal represents as like this, n, and the continuous time signal is represented like this, t, xn, xt. See, that is the difference. Okay. Jean Baptiste Joseph Fourier from, okay, he is the inventor of the Fourier transform. Rows and flowers, these things. Okay. Okay, stock market index. These are also signals. Okay, this is the discrete. But what kind of signal this is? Can you tell me? Is it continuous time or discrete time signal?
Discrete time signal.
Yes, it is
Strict.
discrete. See, it is not the continuous because at the different time of the weeks, let's say the year, a period, January 1929 to December 1929, the share market, the stock exchange status per week. How many weeks per year? 52 weeks. So every week they have the index. Okay. So these are the signals. Continuous time signal, and that is the discrete time signal. If you have the multidimensional, then you can write x of n and m, comma, x and comma m. You can write like this. Okay. Now see, that is the system, right? Input is xt or xn, output is yt or yn. Okay. T T means time domain, n is the number. Domain for analysis and representation, time domain xt or xn. In the frequency domain, Fourier transform, Laplace transform, 3 Z transform. Okay. So in the frequency domain, we need this. We'll see this also later. Fourier transform, Laplace transform, and Z transform in the frequency domain. In the time domain, only xt and xn. Okay. So linear time invariant means linear time invariant, non-linear time varying. See, linear means if we change the time, then it will not vary. But non-linear means if we change the time, it will vary. Okay. So domains for analysis and representation. So two types of domain: time domain and frequency domain. For the time domain, continuous time signal or the discrete time signal. In the frequency domain, we have the Fourier transform, Laplace transform, and the Z transform. Okay. And another thing is linear time invariant. That means the linear time invariant or non-linear time varying. Okay. These kind of signals are there, and systems. There are several systems like series system, parallel system, feedback system. You'll see later one by one. So not all at a time. Okay. Some recording some signals. They have showed some signals there. Same thing again and again. Some examples. Okay, now let's go move on our own topic. Okay, now the signal. So what is the signal? Signal is a description of how one parameter varies with another parameter. So one parameter will be vary according to the another one. That is the signal. So our course name is signal and system. Okay. So some example are there like the an example voltage changing over time in an electronic circuit. That is also signal, right? Voltage is changing over time in an electronic circuit, and the brightness varying with distance in an image. Okay. For our case, the variable is time and frequency. So the two kind of variable are there. One is time, another one is frequency. So we will represent the signal in two dimensions. We will represent the signal in the two dimension. One is amplitude, another one is time, right? That is the amplitude, and that is the time. In the x-axis, it is the independent parameter time, but the y-axis is dependent parameter. Because see the function, time itself is t, but here the amplitude is a function of time, right? Amplitude is the function of time, ft. Amplitude is the function of time, which is the ft, and the time does not depend on other things. Rather, the amplitude depending on the time. Okay, amplitude depending on the time. That is the thing. Okay. Now here C, that is the function of the amplitude depends on time and thus a variable along x-axis. So they can, if we want to see a point over here, say P, it is a function of time, and yt. T here, T is the time when the curve is at P. Y is equal to height per amplitude of the point P at time. Okay, so this is the simple signal. Now classification of signal. So continuous time signal and discrete time signal. You have already seen that. Continuous time signal and the discrete time signals. These are the two major signal. And some other signals are there like the energy and power signal, even and odd signal, real and imaginary signal, periodic and aperiodic signal, deterministic and non-deterministic signal. These are also signal types. Okay, continuous time and discrete time signal, energy and power signal, even and odd signal, real and imaginary signal, periodic and aperiodic signal, deterministic and non-deterministic signal. So we'll see all the signals one by one. This is the classification. Okay. But there are some basic type of signals like the unit step signal, unit impulse signal, and ramp signal. Let me show you what the signals are look like. Unit step signal, the first one would be like this. That is the unit step. Okay, unit step signal. The one unit step, that is UT. Impulse signal, impulse just like this. That is delta t. That is delta t. And the ramp signal, A ramp signal will be like this. Okay, that is the ramp signal. TUT. That is the ramp signal. That is the step, impulse, and the ramp. Three kind of signals. These are the basic signals. Okay, these are the basic signals. Unit step signal, unit impulse signal, and the ramp signal. Okay. Now the continuous time and the discrete time signal. Okay, we have already discussed it, but let us show this. A signal is said to be continuous when it is defined for all instants of time. See, a signal is said to be continuous when you will tell a signal is a continuous when it is defined for all instants of time. That means, let's say you have a time frame, the signal will be on the all over the time, okay, at the different positions, but the signal is there. Okay, that is a continuous signal. But when it will be discrete, a signal is said to be discrete when it is defined at all the discrete instants of time or at the integer values of time. So see the definition. So if I ask you in the Viva, what is the continuous time signal or which one is the discrete time signal? So I think you can show it. All right. Discrete time signal means at the different values, at the integer values of time, you will find the discrete signals. Okay, at the integer values of time, you will find the discrete signals. Continuous time signal, every time, anytime you will get the signal, but the discrete time signal, you will not get it all the time, rather you will get a certain period. Okay. Some the deterministic and non-deterministic signal. See, a signal is said to be deterministic if there is no uncertainty with respect to its value at any instant of time. See, this is a sinusoidal wave. So you can say that at some point, at some time later, when you will get the signal, can be described by mathematical equation. Okay, can be described by mathematical equation. Mathematical equation, by using a mathematical equation, you can describe this deterministic. And the non-deterministic, you cannot define the position of the signal. See the signal type. See, non-deterministic. You do not know when the signal will behave after some time. A signal is said to be non-deterministic if there is uncertainty with respect to its value at some instant of time. They are also called random signal. This is are called the random signal. Okay, deterministic and non-deterministic signals are there. So, these are the definition. Okay. So here is the deterministic and here is the non-deterministic signal. So you do understand which one deterministic and which one
Sir.
non-deterministic, right? You do understand, right? So if you determine the signal, then it is deterministic. But if you do not determine the signal, what will be the signal type after some time? Then it will be random signal or the non-deterministic signal. Okay. So I think you understand. Now see, even and odd signal. See, this lecture is important because here I am giving you some basic idea. Okay, later of the course when you do some maths, then you need these ideas. Okay, so if I let's say in the question I tell you a signal type, then you should understand, oh, that is the signal type. That kind of signal we are going to calculate. Okay, so listen very carefully. Even and odd signal, and another type of signals. Even and odd signal. See this. A signal is said to be an even when its magnitude is equal and symmetrical about t is equal to 0. The even signal satisfies the equation. That is the even signal. See, magnitudes are same, and it maintains a symmetry. It maintains a symmetry. Okay, it maintains a symmetry, and it is a even signal. Okay, it maintains a symmetry, and it is a even signal. See here the 1 at the position 1. If you look at the magnitude, amplitude is same, and at the -1 you will also get the same amplitude. So it is a even signal. What would happen if it is the odd signal? In the odd signal, magnitude will be different. A signal is said to be odd when its magnitude is equal and symmetrical but opposite about t is equal to 0. The odd signal satisfies the condition. See, it is opposite. In the odd signal, the amplitude magnitude is same, okay, but it is opposite. It will be opposite. This kind of signal would be the odd signal. So that kind of signal is the even signal, and this kind of signal is the odd signal. Okay, even and odd, two kind of signals are there. So for the even, see, a signal is said to be odd when its magnitude is not equal and symmetrical but opposite about t is equal to 0. The odd signal satisfies the condition xt is equal to minus x minus t. See, some conditions are there, like any signal can be resolved into two parts. They are even component x xet and the odd component xet and the odd component x naught t. Even and odd component are totally different from even and odd signals. See, even and odd components are different, not the same thing. Let's see, if a signal is xt and we can break it by two parts, xet and x naught. Xe means the even, xo means the odd. Now xct is equal to xt plus x minus t by 2, and xot xt minus x minus t by 2. These are the formula for xc and x naught t, even component and odd component formula. Okay, so the conditions are xt is equal to x minus t, and here for the odd xt is equal to minus x minus t. Okay, so minus will be there in the condition. Okay, so remember the condition here. Xt is equal to x minus t for what? For the even signal, for the even. Okay, and for the odd, xt is equal to minus x minus t. That is the odd signal. The condition, two conditions. They have to satisfy these two conditions. Okay, these are the requirement. Okay, as two types of components are there, even component and odd component, and some equations are there. So if you look at the even component, and this is the equation, and if you look at the odd component, this is the equation. See, even x minus t and the odd minus x minus t. Okay, another kind of signal, periodic and aperiodic. A signal is periodic if it is repeats for every time interval equal to time period. The condition for the periodic signal is ft plus t naught. T naught is the fundamental time period. F naught is equal to 1 by T naught is the fundamental frequency. See, periodic signal, so I think you understand, normal sinusoidal signal is a periodic signal because it repeats after some time. After some time it will repeat. That is the periodic signal. And the non-periodic signal, after it does not follow any period. A signal said to be non-periodic if it does not repeat after some fixed time. Okay. So it is a simple thing. If it is periodic or not. Okay. A simple thing. Say it if it is periodic or not periodic. When it is periodic, when it changes. Okay.
Again,
So
sir.
okay, so the periodic signal, that means after some time it will repeat, signal will repeat. Okay, just look at the figure here. This is the sinusoidal signal. After this time, it also repeating, right? Same signal again and again. But
Yes.
in the non-periodic, signal changes, right? Signal changes. Here you need a Fourier transform. Okay, we'll see it later. But the non-periodic signal, it is not periodic. But in the periodic signal, after some time, it will repeat. A signal is periodic if it repeats, see the term repeats for every time interval, Okay, after some time, it will repeat again and again. Okay,
Okay.
that is the periodic signal. But the non-periodic signal, it will not repeat. Okay, that means you do not know. Okay, you cannot guess first, but you have to calculate. Okay, a signal said to be non-periodic if it does not repeat after some fixed time. Okay, so that is the type of periodic and non-periodic signal. Now, another kind of signal is the energy and power signal. A signal is said to be an energy signal if its energy is finite and average power is 0. And a signal is said to be power signal if it has finite power and infinite energy. See, it is just the equation. You will see from the equation. Let the energy signal minus infinity to infinity x square t dt, where p average is equal to 0. Average power is equal to 0, and the range is 0 to infinity. Energy is finite. Energy signal, if it is energy is finite and the average power is 0, and the signal is said to be power signal if it has the finite power. Power is finite. See the here that condition, power is finite and the energy is infinite. That is called the power signal. See the power signal equation. T tends to infinity. Okay, time tends to infinity. 1 by t. Integration of minus t by 2 to t by 2 x square t dt. Okay, that is the equation for the power signal. So two equations, two conditions. See the conditions very carefully. In the energy signal, the energy is the finite. Energy is the finite. On the other hand, power is the 0. Average power is 0. Or if you look at the power signal, then the power is finite, but the energy is infinite.
0.
Right, not 0, infinite. Energy is infinite. The power signal energy is infinite. See.
Okay.
Okay, just look. Remember the conditions. What are the conditions? energy signal conditions, and here are the power signal conditions. Okay, equation and conditions. I'll repeat those things again. Okay, today I'll just show you the types of signals. Okay, I'll not give you burden, just types of signals. Okay, see another real and imaginary signal. So I think you know that a signal is said to be real if it satisfies the condition, that is the real signal, and if it is the imaginary signal, it is the minus conjugate of xt. For the real signal, imaginary part is 0, and the imaginary signal, real part is 0. Okay, and they explain again those things. Okay, now let's just come from the beginning again. So what we have seen so far, we have seen that there are two kinds of signals. First, continuous time signal and discrete time signal. Okay, so what is the continuous time signal? So you can explain the time anytime. All right, continuous time signal. On the discrete time signal, it will, you have to, you cannot uh, find a signal every time, everywhere, but rather you will find a signal at the discrete point, the discrete values. Okay. And the deterministic and non-deterministic signal, the deterministic signal is the normal signal, so you can understand that after some time you can guess the signal position, but the non-deterministic signal you cannot define the position after some time because it changes. Even an odd signal, even signal has the symmetry and the same magnitude. Odd signal has the same magnitude but does not maintain the symmetry. That is the even and odd signal difference. And some equations are there like the even signal equation the xct and odd signal equation x naught t. A periodic and aperiodic signal. Periodic signal has maintains the period. The non-periodic or aperiodic signal, it does not maintain the period. Okay. And energy and power signal. What is the energy and power signal? Some equations are there. Energy signal has the finite energy and zero average power. On the other hand, power signal has the finite power and infinite energy. And here the real and imaginary signal, just you know the real part. In the real signal, it does not have the imaginary part. On the imaginary signal, it does have the real part, which is 0. Okay. And here they discussed even and odd signal more. Let's see it. Even and odd signal. Okay, here the even and odd signal. Even signal means what? The signal which remains identical under folding operation. That means the time reverse is called the even signal. See, in another word, the signal whose magnitude is equal and symmetrical about is called the even signal. The condition is xt is equal to x of minus c. That is the condition of even signal. We also know that. And odd signal, the signal whose magnitude is opposite but symmetrical about t is equal to 0 is called the odd signal. The condition of odd signal is xt is equal to minus x minus t. And in another word, the signal whose amplitude reversal happens under folding operation. That means the time reverse. Whose amplitude reversal happens under the folding operation. That means the time reverse. That is called the odd signal. Here are some example of the odd even signal and odd signal. See, look at the examples. Even and odd signal examples are there. See, try to understand. Some examples are there, even and odd signal examples. Okay. See what is the value here? The symmetry. It maintains the symmetry. If you look at here, it maintains the symmetry. Here the 2, the -2, and here the 3 and the -3. Same kind of signal, even signal. And the odd signal, see, the difference are here. This kind of signals are odd signal. At t is equal to 0, at t is equal to 0, the value of odd signal must be 0. The odd signal value must be 0 is equal to t equal to 0. The average mean value of an odd signal is 0. Okay, see, x t is equal to cos t. X minus t, cos minus t is equal to cos t. So the xt is equal to x minus t. So this kind of signal is the even signal. But x t is equal to sin t, x minus t, sin minus t, but that means the minus sin t. So x t is equal to minus x minus t. So so the sin t, it is an odd signal. So see, cos t is a even signal and sin t is a odd signal. T to the power n is equal to, where n is equal to even signal, and the n is equal to odd, the odd signal. Okay, see this thing, t to the power n here, if n is the even value, then it will be even signal. If the n has the odd value, then it will be odd signal. Okay, now see, even and odd component. Every signal can be resolved into two parts. They are even component and the odd component, what we have discussed earlier, where even component is the xt plus x of minus t by 2, and the odd component are xt minus x of minus t is by 2, and the summation of even component and odd component gives the total signal. Okay, and some properties are there, even an odd signal, like even signal value, DC value, direct current value, plus even signal, even plus even plus odd, they're even or odd. Okay, so I think we'll discuss these things later. Okay, so I think up to this today is enough, even an odd signal. Okay, up to the
Yes, sir.
basic, right? So if we move further, then it will be, I think, more pressure to you. What do you say? Will I move forward
Yeah,
or just stop?
yeah, stop, sir.
Stop, right?
Yeah,
Okay. So today, just a recap. So today, what we have seen? We have seen several types of signals. Okay, like the basic kind of signals and even and odd signal types. Okay, what are the conditions for the even signal and the odd signal? X is equal to minus x of minus t, and the odd signal xt is equal to minus of x of minus t. Okay. Uh, okay, now can you guess the type of signal? Let's say, what kind of signal this is? Can you tell me?
non-periodic signal.
Yeah, non-periodic signal or aperiodic signal. Okay, good, very good. And This kind of signal?
Even.
Odd. Odd, odd.
Or signal.
See this odd signal. This is the odd signal. That is the odd signal. And
What signal, sir?
this kind of signal? Can you tell me what kind of signal this is?
Discrete signal.
Discrete signal.
Discrete.
Discrete. Yeah.
DT, that means the discrete time signal.
Discrete time signal. Yeah.
Okay. It is continuous time signal, right? Continuous time signal. It is also considered continuous time signal, but it is non-periodic signal. Okay. So we can classify the signals at many types,
Yes, sir.
right? Like many kinds of signals are there. According to the properties, we can identify the signals. So if we do the math, then we'll understand that how to solve these things, how to find out the property or how to understand what kind of signals will be there. Okay. So these things.
Okay.
Okay. So I think you have understand well today, right?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir. Well,
Inshallah. So if you think that you do not understand, then just inform me. Okay, then I'll try to show you more examples. Okay. So what is your home task? That means at your free
Sir.
time, just look at the lecture what I have discussed today. Okay, just look at the signals. Try to understand without looking at the book or without looking at the lecture sheet. You can identify the signals or not. Okay, so if you identify the signal, then okay, you have understood. Okay, so these things are important. So I will give you this sheet now. Okay, this lecture sheet.
Yes,
Some
sir.
examples are there. Okay, this is not mine actually. This is from your Munim sir, because he is taking the signal and system courses. And this is not, and I am not taking this one previously. So I do not have my own lecture sheet, but I have my lecture sheet of my university. Okay, when I was a student like you, at that time we have took the note, class note. I have that notebook, so I can show you from them, from that. But the thing is, that is the very old one. I think almost 12 years ago, at the 2008 or 7 at that time, I was a student of university. So very old one. So, but your Munim sir's sheet might be the more modern. Okay. So
Okay, sir.
I'm stopping the sharing. So how many students are today? Only 9.
yes, sir.
6, 9, 20, 20, day 28. Okay. Let me check the attendance. So roll 1, 3,
Yes, sir.
6, 8, 9,
Also 2.
12, 18, 17, 2.
Yes, sir. 12. 12.
Yeah, 12,
Yes, sir.
Sir, 8.
8, yes. So yeah, that is your good idea. Just putting your roll number in front of your name. That is
Sir. Yeah.
good
That's
idea.
good.
Okay, sir.
Yes, sir. We're right.
Yeah, you are right. See, so let me check again. 1, 2, 3, 6, 8, 9, 12, 17, and 18.
Yes, sir. All right.
Yes,
All
sir.
right.
Yes,
Yes,
sir.
sir.
Okay, just I took your attendance at my notebook. So you do not need to give it
Okay,
to
sir.
me in the messenger. Okay, you no need.
Okay,
And
sir.
Okay, sir.